Welcome to Eureka Math. I'm Mr. Shankel. Today I'm going to be helping you with Module 1, Lesson 17, and this is Part 2. Let's get back to work. All right, we left off by working our way into changing the scales so that all of our ordered pairs would fit on the coordinate plane, and we're now trying to take a look at a situation where our numbers are extremely small. In fact, all of the x values are less than 1 or greater than -1. So they're all within a small space. In fact, if we were to graph those, then our x values would be between -1 and 1. So our space here is not being fully utilized. What we want to do is expand this the number line, our scale, so that we use all of the space. And the way that we'll do that is we take a look at all of our x values. So we're going to change our x scale, and looks like the biggest one is a 0.8. So I know that if I made these 10 lines here, each worth 0.1, that would maximize my space pretty good. I could take as big as it is 0.8 and then, oops, I'm on the wrong tool again. I could take 0.8 and I could divide it by 10 spaces, and it would give me exactly what would completely maximize. But then I make my intervals a little more difficult, and we want to keep them as simple as possible. So I'm going to make each one of these grid lines, worth 1/10 or 0.1. So I'm going to skip, and I'm going to say that's 0.2, and then 0.3 is here, and then 0.4, and then 0.5, and then 0.6, and then 0.7, and then this one would be 0.8, and then 0.9, and then I would be all the way out here at 0.10. All right, and then on the negative side, we'd have a -0.2, a -0.4, a -0.6, a -0.8, and a -0.10. Now, sorry, -0.10, -1.0 is what we should have there. That's 1. Okay. So now my x-axis is maximized. If I look at my y values, my biggest y value is a 7. That's going to get me pretty much up there. So I'm going to leave those at each worth 1. So we're going to stay at, let's see, we're going to stay at 2, and then 4, and then 6, and then 8 is up here. And then down here we'd have a -2, a -4, a -6, a -8, etc. All right, now we can plot those. So let me change the size of my pen here so we can plot them easily. 0.14 means I would go right to 0.1 and up to 4. That one's there. 0.57, right to 0.5, up to 7. Right there. -0.7, -5. So left to -0.7, which is here, and then down to -5, down to 5. So that's that. Okay, so now look, we're using all of our space. Left to 0.4, up to 3. That one's there. Right to 0.8, up to 1. That one's going to be right there. All right, so we've taken that x-axis and we've expanded it so that we are using more space rather than confining everything between 1 and -1. Okay, let's look at the next example. This time looks like we're going to have to change both scales maybe, because I've got a -14 here I see on the x value, and there's a +14. And yeah, so I've got to at least be that big. So I'm going to have to expand this a little bit. So 14 is my biggest number for my x value, and I have 10 spaces. Well, 10 goes into 14 one time, and 1 times 10 is 10. Subtract, and I get a 4, and I bring down a 0 and add a decimal here, and 10 goes into 44 times. So 1.4 is what each space should be, each grid line, so that I make sure that I get 14 in there. If I make them each 1.5, it's a little easier numbers for me, so I'm going to do that. I'm just going to decide to make it just a little bit bigger. So my x values, this is 1.5. The next one would be 3. And then 4.5 is here. And the next one would be 6. And then 7.5 would be here. And the next one's 9. And then 10.5 would be here. And the next one's 12. And then 13.5 would be here. And the next would be 15. So I get 15 is as big as I get, and I just need it to be at least 14, so it fits. So every other one's going to be worth 3. So this is going to be a -3, a -6, a -9, a -12, and a -15 all the way out here. So there's my x-axis. And now let's take a look at the y's. I've got a 2, a -0.5, a -3.5, a 2.5, a 3.5. So 3.5 is our biggest number, our most distance away from 0. So I'm going to take my 3.5 and I'm going to divide it by my 10 spaces that I have. And 10 goes into 35 3 times. 3 times 10 is 30. And if I subtract, I get a 5, and I add a decimal, and I bring down a 0, and 10 goes into 55 times. So I know that if I make each one of these, well, not true, is it? Because I've already had a decimal here. So my decimal goes above. So it's really a 0.35 is what each space is going to be worth. And that's going to make some weird numbers. So I'm going to make it a 0.5. I'm going to make every number worth a half, which means every 2 numbers is worth 1. So there's 1, 2, 3, 4. 4 is there. And then 5 up here. Come on, 5. All right, and then same thing, a half, and then -1, and then -1.5, and then -2, and then -2.5, and then -3, -3.5, and then -4, -4.5, -5. And now I think you'll see that we can fit all of these on the same coordinate plane. So let's see, left 14, which is going to be just a little bit past -13.5, and then up to 2, so about right there. Left 4, and then down to 0.5, which is about right there. Right 6, down 3.5. Right 6 is there, down 3.5 is there. Right 14, and then up to 2.5, so about right there. 0, up 3.5, right there, and then left 8, and then down 4. Left 8 and down 4 is about right there. So notice that we've used all of that space, even though we had different scales for each x and y axis. Okay? So take the biggest change from 0, the biggest distance from 0, divided by the number of spaces that you have, number of grid lines, and that will give you a good idea of what your interval should be. All right, that's lesson 17. I hope that helps. See you again next time.